Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss about remaining two properties of transaction, which are isolation and consistency. And in any RDBMS system, RDBMS supports four different types of isolation level. So four types of isolation, and those isolations are read uncommitted, then it's called read committed, and number three is repeatable read, and number four is called serializable. Okay, so these are the four different types of isolations. Transactions isolation is supported by RDBMS system, and depending on which RDBMS you are using, that they will use different types of isolation level. And when maybe these all these things terms are looks very weird, like read uncommitted, and basically I'm just looks like I'm just changing those word, and then I'm telling you isolation levels. But what I'm going to do is I'm going to explain you each of them on three different types of occurrences or three different phenomena, and those phenomena are one called dirty read. So as the name suggests, it will read dirty data. That means, let's say for example you have a table T, and table T's rows are somehow stored like this. Okay, so 1 2 3 4 5 6, and let's say so while I'm trying to read this table's data by a select statement, somebody else and then can come and then update so this value. So that's value to 8, but he has not committed it. Okay, so that means this is something updated value, but it has not been committed, and we do not know if that guy is going to commit or roll back. Okay, but whenever we are going to read, if you read the new value, then we are reading some dirty elements. Okay, so that means if the phenomena is dirty read, so this is what does it mean by dirty read. And number two is non-repeatable read. Okay, so in case of non-repeatable read, same example, we have a table T which has multiple rows, and let's say somebody has gone and updated this thing, okay, 8 to 10, and maybe he has committed. Okay, but whenever this query started, that time the value was 8, but as the query progresses, somebody has just in the meantime somebody might have come and then updated it. So if we read that one, then it is not repeatable, because if I want to run this same query again after some time, maybe I'm going to get some different values. All right, so basically you may not get same answer if you read a row at a different time. So let's say time t1 we read, and then we got the initial value was 8. At time t2, after this update, somebody has changed this thing. Whenever you go on and read, you're going to see another value. So therefore this is called non-repeatable read. That means if I run the same select statement at two different times, I'm not able to see I'm not able to get the same result. And number three is called phantom read. Phantom read. So in phantom read, what happens is that it's the same as non-repeatable read, but there is a very subtle difference. In phantom read also, I'm going to see different results at different time for same query. But in case of phantom read, whatever data we read, those data will remain same. That means nobody has updated anything. Okay, but somebody might have inserted some new rows. Okay, so somebody might have inserted a new rows. So at time t1, let's say at time t1 I have only 10 rows. So whenever I'm selecting at time t1, I got 10 rows as answer. But after that, somebody has gone and inserted two more rows. So at time t2, whenever I'm doing the same query, I'm going to get 12 rows because somebody has added this thing, and that is called a phantom read. So non-repeatable read and phantom read is going to give you different results at different time for same query. In case of non-repeatable read, we have an update to an existing data, and that is the reason why we are going to get a different result. But in case of phantom read, we somebody has inserted more data, but whatever data was read before, those data are remain same. That means no update but insert. Okay, so these are the three different phenomena that basically required to explain all these four different types of isolation level. So if I will draw in a two-dimensional array, so let's say like try to make, so let's use some, so let's make a table like this. So we have something like this. Okay, so here I am going to put my isolation levels. So this is called isolation levels, and then this side I'm going to have my three different phenomena. Okay, so the number one is dirty read, number two is non repeatable read, and number three is phantom read. Okay, so what we're going to do, we're going to see like what kind of transaction level supports what kind of occurrences or what kind of phenomena. Okay, so the number one is read uncommitted, and then we have read committed, repeatable read, and serializable. So in case of a read uncommitted system, we are supporting all these dirty reads, non-repeatable reads, phantom read. So that means like whenever we have a read uncommitted system, let's say take an example, we have an account table. In account table we have, it's a big table. Let's say you know we have only for simplicity we have two columns. One is your account number and then amount of money on that account. Okay, let's say account number 1, then account number 2, account number 3, like this. Let's say I have up to say 200,000 rows. Okay, so this is account number 200,000, and let's say this amount is 500, 300, 200, and so on. And then let's say I have this is 1000. So what I'm going to do is at 7 a.m. somebody run a query that go or select sum of amount from account. So at 7 a.m. whenever you run this query, then whatever is amount of all these things will become, and then let's say that amount is X. Okay, so what is going to happen is in the select oh sorry, I just want to make I made a mistake. So at 7 a.m. somebody is going to run this select statement, and since there are 200, so the way that this select is going to run, so this is going to get a value 500 plus 300 plus 200 is going to go on, add them up, and then finally going to give you a number. Maybe this query is going to take a long time because there are 200,000 rows are there. Okay, let's say the query is going to take 4 seconds. Okay, so that means at 7:04 a.m. this will give me a result, and that result will say X. Right, let's say at 7:01 a.m. somebody else has come and then remove $100 from this account, so this account become 200, and add $100 to this account, the last account 1100. Okay, so 7:01 transfer 100 from number 2 account to number 200,000 account number 200,000. Okay, so at 7:1 a.m. if you are going to do that, so let's say by 7:1 a.m. this select statement has already read the old value, that means the 300. Okay, so because in 1 second maybe it has, there are 400 in a 4-second text to complete this transaction, to completely read all this thing. So maybe after 1 second it has already read 50,000 rows. So therefore, the transaction that is started at 7 a.m. might have already read the old value that was 300. Okay, so it has already considered 300 here, where it should have considered 200. Okay, don't worry. And then we are keep continuing, and eventually this transaction which is started at 70 is going to read what is the value at 200,000 account number. But whenever he is going to go there to 200,000 account number, he is seeing this new value which is 1100. But remember, this 1100 was not there when the transaction started at 7 a.m. And if he is going to read this thing, that means he is reading a dirty amount. Why is it dirty amount? Because as the name suggests, we have already accounted as 100 here in 300. So therefore, instead at 704, if this situation happen at 7:01 a.m. we are going to transfer, then at 7:04 a.m. we are not going to get X, but we are going to get $100 more. Okay, so why this $100 coming more? Because we have already considered 300 here, and then when we're coming we are also adding 1100. Had you add 1000, then it would have been okay. So this is called dirty read, and as you see, dirty read is not good at all. And then, by the way, Oracle does not support this thing. Oracle uses a multi-versioning database system which can use to read the old value even if the value has been changed. Okay, so Oracle does not support. And so in case of a read uncommitted isolation level, dirty read is possible. And also assuming that at 7:01 a.m. somebody has just updated, okay, some account, again we are going to read another dirty value. Okay, and maybe like us at 7:01 a.m. somebody has added couple of more rows. So in that case we are going to have phantom read. So therefore, in read uncommitted thing, all these occurrences are going to happen, which are all bad, by the way, because from the transaction point of view we should get a consistent result whenever you want to run. Okay, so if you understand read uncommitted, now let's try to understand what is read committed system. All right, in case of read committed system, the RDBMS system does not allow any dirty elements to be read. However, it may give different amount of different result at if the query is run at different time. For example, let's take this, I'm going to copy this thing. So let's assume that we have the same transaction. Okay, so let's assume that we have the same table where we have account is like this. I'm just going to clean it out so that I can explain it a little bit better. Okay, so let's say I have same 200,000 200,000 rows, and then I have all this amount is maybe 100 1,000, something like that. Okay, so in case of a read committed system, if I am seeing a dirty element, then I'm not going to read that. However, if you are doing, if you are inserting something, at time t1, let's say you start a transaction, and while this transaction is happening, so basically you did select some amount from account. Let's say you get X. Okay, and then while this query is running, if somebody is going to change something and that is a dirty read and I'm not going to read that, I'm going to do away somewhere like the old values or whatever this thing, right? Let's say at time t1 plus 5 second, somebody else has gone and updated. So remember, this query is already finished, right? The first query is already done, and after that somebody gone updated something, and let's say this updated to 2000. And if I'm going to run this query, select some amount of account, then I'm going to get a different result because this is updated to 1000 plus 1000. Okay, so that is essentially a, like, if you look at your this thing, so that is a non-repeatable rate. Okay, so like I am not, there's no guarantee that I'm going to get same result if I run the query at the same query at two different point of time. Similarly, if somebody has gone and inserted something, then if I run this query at different times, I'm going to get a, a result that is also inconsistent. That is also not same as I run before. So that means what I'm saying here, that as long as this transaction is, is going on, I expect from the transaction context point of view, I expect that the results would be same. But there is no guarantee in a read committed system that I would get that, because I'm going to read the non-repeatable read and also the phantom read. So therefore, a read committed database system supports non-repeatable read and phantom read. Okay. The next one is called your repeatable read. Okay. So the goal of this repeatable read is to give a consistent and correct result across transaction. Okay. So let's take an example. If we have a table T and assume that in table T, or you take that case of the account table that we are discussing, right? So this account tables data is going to be stored in data files like this in a data blocks. Let's say this is the block 1. In block 1, let's say I'm just saying for simplicity, I'm having one row in one block. So this is the block 1. In block 1, I have account number 1 and let's say amount is 100. And this block 2, account number 2, amount is a 200. And block number 3, let's say amount is 300, and so on. And I have block number, sorry, account number 200,000. Let's say I have also $100 there. So this is how the account table is basically stored in the data file. And let's say we are doing select some amount from account table. So if you are doing that, and then whenever we are going to go on and read from this, from this data block, what we are going to do, we are going to avoid any dirty reads. Also, we are going to avoid any non-repeatable reads. That means if somebody has modified anything, then we need to avoid. Okay. So the way, like now, while you are doing this select here, and then somebody from another session, okay, this goes there, and then let's say he updates, like we have, let's take an intermediary row, and let's say this account number is 100,000 and amount is 200. Okay, let's say somebody update the account number 100,000. Okay, so if he updates the account number 100,000, then what happens? Two way: either you don't allow to update happen because some query is going on right now, or some, or some transaction is going on if the query is already finished, because still it's a part of transaction, right? Is nobody is doing any commit or anything in the session one. So what is the way it is going to happen, that whenever it's going to update this thing, then whenever it reaches here, either what you can do, you can have a lock here so that this person cannot update, or, and then if you lock it, then you are basically introducing a delay, right? So somebody else is going to wait for that, so you are introducing a wait. So instead of that, what Oracle does, it update, if you want to do an update, so okay, this goes and update here. Okay, so update the new value or whatever. But remember that every data block in Oracle consists of a header. In that header, what you store? We store about what kind of table and all those things. And one important thing we store, that is called SCN number or system change number. So let's say whenever this transaction started, the system change number was 100. So that means all these blocks will have 100. But whenever, while this thing is going on, this update happened, and then let's say this guy is commit. And if commit, then at the commit time, remember, we are going to generate a new SCN number. Since SCN number was 100 before, let's say this SCN number is 101 now. And then what are we going to do? The commit is going to update the block that is updated. In this case, this is 100,000 with the value 101 as its header. So now whenever we are reading, so basically this query is keep reading here, and then it is going to keep reading to the blocks which has an SCN number 100, because this query started when the system change number was 100. Therefore when it comes and see this block which is 100,000, he sees that the SCN number is changed, is not anymore 100. Then what it's going to do, it is going to reconstruct a duplicate value from the undo segment or rollback segment. So whenever it comes here, it take a detour. So it is not going to read the data here because it knows that okay, 101 SCN number is not that what I supposed to read. Then it's detour and then reconstruct the data from the undo segment or rollback segment. So this is something different because Oracle maintains all those old values and all this thing. So whenever there is an update happens, we also maintain the new value and what is the old value that was there. So then that means what is going to do, somewhere in the undo segment we have the old value of this 100,000, whatever the amount, the old amount, and with that old amount we have this SCN number is 100. Okay, so then it goes to there and then read that whatever the old value and then finish this query. So in this way Oracle is going to give you a repeatable read anytime you read. Okay, so this is what is all these things about called multi-versioning system in Oracle. Okay, that means whenever you update, and let's say after this update somebody else got another update. If another update, then the SCN number become 102 here, and then in a rollback segment we have this 100 old value, and then whatever the value for 101 SCN number, that should be another value. Okay, and then so depending on when the transaction started, if the transaction is going to start at 101, then I'm going to reconstruct from this value. And we're going to discuss more detail on the rollback and undo segment about the internal mechanism, how this works. But from the transaction repeatability point of view, you're going to get always a repeatable read if in this case. However, if somebody instead of updating, he goes and then do insert. If somebody inserts, then we are going to have new value. Okay, and this is and then by the way, like we don't have, because we don't, like if you do a so in that case what we're going to do, we are going to get a phantom read. Okay, so therefore in your repeatable read this thing can possible. The last one is serializable isolation level. So serializable, in serializable what you do, this serializable transaction operates in an environment that makes it appear that there is no other transactions are running. Okay, so let's say for example you do at time t1, you do select star from t, and let's say you after that you don't do anything and then you sleep for 24 hours, and then let's say select star from t, it has give you say 10 rows. Okay, and then after t1 plus 24 hours, if you do select star from t, you will get exactly same 10 rows. Okay, so what happens to other people? I know if there is another guy who is going to update table T, what he's going to get? He's going to get an error, say ora 8177, saying that you have to, if you want to update T1, you have to wait, because what happens is that we put a lock here whenever you do a select start from T in the serializable mode. So that means the all, like, if somebody does that, then what happens is that all other people who wants to do an update is just waiting for these things to finish. And let's say if even after t plus 24, if somebody do a commit here, then update is going to go through. So serializable is the highest, level, of isolation, but this level of isolation severely restrict the concurrency. As you see in this example, at this database, just only one operation can happen. But however, in a OLTP environment where, like, we have a lot of short transaction and they just happen right away, in that case, this kind of serializable may be a good way to give you, to do those kind of things. But serializable is always going to give you consistent result, no matter of what it is. So therefore, serializable does not support any of this. Nothing is, so I don't want to click anything on here because it's not going to support dirty read, it's not going to support non-repeatable read, neither phantom read. So this is all about your transaction isolation level, and how this transaction isolable level gives you consistent views, consistent result and correct result. And Oracle supports only these two isolation level, repeatable read and serializable.